So here is how important some rare earth elements are. An F-35's flight actuators needed. So does the motor in a Tesla, the coating on a jet turbine blade, and the guidance system on a Virginia-class submarine. And these two elements, specifically, dysprosium and terbium, that let magnets keep working at the kind of heat that would demagnetize an ordinary one. There is currently exactly one country on Earth with the industrial capacity to separate those two elements out of raw or at meaningful scale. You already know which one. This isn't a resource scarcity story either. It's not that dysprosium and terbium are rare in the sense of hard to find. It's that almost nobody else on the planet has bothered building the specific, difficult chemistry required to pull them out of the ground and into usable form. Here's the thing. You've probably heard a version of the US-China standoff over semiconductors, chip bans, export controls, retaliation, escalation. That fight is real, and this show is about to spend an episode on it. But the chip fight is a fight over one input to modern technology. This episode is about a different input, one layer further down, that almost nothing in modern manufacturing works without, and where the leverage isn't close, isn't new, and isn't really about chips at all. Before this show can tell you what happens when one government restricts semiconductor exports to another, it needs to tell you what happens when the same government controls the substance the semiconductor economy quietly runs on underneath. That's this episode. Chips are the symptom. This is the disease. Start with the number everyone gets slightly wrong because it's the number that makes this problem sound smaller than it actually is. China mines roughly 70% of the world's rare earth elements. A big number but not an unbeatable one. Deposits exist in Brazil, Vietnam, Australia, even the United States. If mining were the whole story, this would be a 5-year problem, not a 30-year one. Footnote 1. Here's the actual choke point. China doesn't just mine the ore. It refines somewhere between 85 and 91% of the world's usable rare earth oxides, and produces around 94% of the world's finished rare earth magnets. The form these elements actually need to be in before a factory anywhere can put them in a motor, a turbine, or a missile. Footnote 2. Mining rock out of the ground is the easy part. Separating 17 chemically near-identical elements from each other at industrial volume, without the process costing more than the metal is worth, is genuinely hard chemistry. Rare earth elements sit so close together on the periodic table, and behave so similarly, that isolating one from its neighbors typically requires hundreds of repeated extraction cycles rather than a handful. And for the heaviest, most magnet-critical elements, dysprosium and terbium among them, China isn't just the leading producer. It's close to the only one. Footnote 9. That gap didn't happen by accident, and it's worth naming the two forces that opened it. First, decades of direct state subsidy. Beijing treated rare earth refining as a strategic industry to be built, not a market to be won, starting in the 1980s. Second, and this part is less discussed, everyone else let their own capacity go. It's worth being specific about why everyone else found that so easy to do, because the separation chemistry itself is a genuine deterrent, not just a matter of political will. Rare earth ore doesn't come pure. It arrives bundled with radioactive thorium and uranium as byproducts of the same geological processes that concentrated the rare earths in the first place, meaning any refinery has to solve a nuclear waste disposal problem before it solves a metallurgy problem. The separation itself runs through hundreds of sequential chemical extraction stages to pull 17 near-identical elements apart from each other, an energy and reagent-intensive process that produces genuinely toxic tailings. China built out that capacity while its environmental permitting regime was considerably more permissive than what a Western refinery would face today, which is part of why undoing the gap isn't simply a matter of writing a check. The United States had a domestic rare earth magnet industry as recently as the 1990s. Magnequench, a GM spin-off that made rare earth magnets for American defense applications, was sold to a Chinese state-linked buyer in 1995. In one of those details history didn't need to invent, Deng Xiaoping's own son-in-law installed as its new chairman. Footnote 10. Within a few years, the company's U.S. production had relocated to China entirely. Nobody forced that sale. It was, at the time, an unremarkable corporate transaction. There's a line that shows up in nearly every article written about this topic, and it's worth citing properly rather than just repeating it. In 1992, Deng Xiaoping reportedly told an audience in Inner Mongolia, "The Middle East has oil, China has rare earths." It's usually deployed as proof Beijing planned this decades in advance chess move style. The honest complication. The quote didn't actually enter Western reporting until a 2009 New York Times piece, 17 years after Deng supposedly said it, and researchers who've gone back through 1992-era Chinese press coverage have found Deng's actual point was narrower, a comment on resource endowment and reserve size, made in the specific context of the Gulf War, not a stated business strategy for weaponizing supply. Footnote 3. The reserves genuinely are there. China holds an estimated 44 million tons of rare earth oxide equivalent, about 48% of the world's known total. Footnote 2. The master plan framing came later, applied backward onto a much vaguer original remark. This isn't the first time this leverage got used, and the first time is worth understanding on its own honest terms, complications included. In September 2010, a Chinese fishing trawler collided with two Japanese Coast Guard vessels near the disputed Senkaku Islands. Japan detained the captain. In the diplomatic fallout, China's rare earth exports to Japan, its largest customer at the time, abruptly dropped, alongside a roughly 37% cut to overall export quotas. Global rare earth prices spiked. Japanese manufacturers, especially in electronics and autos, scrambled. Some rare earth oxide prices reportedly rose several 100% within months, and Japanese firms accelerated a decade-long push to diversify supply and cut rare earth content out of their own product designs entirely, a defensive shift the industry still hasn't fully reversed. It's remembered today as the textbook case of Beijing weaponizing rare earths. The honest complication. No Chinese official ever confirmed an embargo, and there's real reason to think the quota cuts were already planned for domestic conservation and pricing reasons, running on their own schedule, and simply landed on top of the diplomatic crisis rather than being caused by it. Footnote 4. What's not in dispute is how the rest of the world read it, as proof the lever existed and could be pulled. Planned or not, that perception is what mattered afterward. 15 years later, that same lever is being pulled again deliberately and on the record, and the escalation is specific enough to date. China placed licensing requirements on gallium and germanium exports in July 2023, then rare earth magnet manufacturing technology in December 2023, then antimony in August 2024. Footnote 5. In December 2024, licensing became an outright ban on gallium, germanium, antimony, and superhard materials specifically to the United States. Footnote 6. Then in April 2025, came the announcement that actually matters most for the magnet supply chain. Licensing requirements on 7 medium and heavy rare earth elements: samarium, gadolinium, terbium, dysprosium, lutetium, scandium and yttrium, plus their magnets, alloys and compounds. Footnote 6. That's not a symbolic list. Terbium and dysprosium are the two elements Section 1 already named as functionally irreplaceable in high-heat magnets. Scandium goes into aerospace-grade aluminum alloys. Yttrium coats jet turbine blades. Footnote 7. Here's the human-scale version of what that meant within months. The same magnets in an F-35's actuators, a Tesla humanoid robot's joints, and a Virginia-class submarine systems all run through a licensing choke point one government controls. Footnote 9. In October 2025, China widened the net further still, adopting a rule modeled explicitly on the U.S.'s own extraterritorial export control playbook. Any foreign-made product containing 0.1% or more Chinese-origin rare earth content, anywhere in the world, would need a Chinese export license to move. Footnote 6. That measure, alongside several others, was suspended for 1 year in November 2025 as part of a broader U.S.-China trade deal. Footnote 8. What wasn't suspended and remains in force as this episode is being written: the April 2025 licensing regime on those 7 heavy elements, the one that actually touches the magnets. A May 2026 summit produced a U.S. fact sheet describing China as agreeing to address specific rare earth shortages. China's own official readout of the same meeting didn't mention rare earths at all. Footnote 7. For levers exist, and each one runs into the same wall from a different angle, on a different timeline. Build domestic refining capacity. The United States' flagship effort is MP Materials' reopened Mountain Pass mine, which produced about 1,300 tons of separated rare earth oxide in 2024, alongside a new magnet plant in Fort Worth targeting roughly 1,000 tons of finished magnets a year. Footnote 10. China produces over 300,000 tons of magnets annually. The gap isn't closing within any time frame that matters to this episode's audience, and Mountain Pass still lacks the capability to separate heavy rare earths like dysprosium and terbium at all. Diversify to allied producers. Australia's Lynas Rare Earths, running a mine at Mount Weld and a separation plant in Malaysia, is the leading alternative outside China, supplying 5,000 to 6,000 tons of key oxide annually and expanding into U.S. operations. Also footnote 10. Genuinely real, genuinely growing, and running into its own friction. Lynas's Malaysian facility has faced years of local opposition over radioactive thorium byproduct disposal, a reminder that refining capacity isn't just expensive to build, it's also politically difficult to site anywhere, including outside China. Footnote 12. Stockpile strategically. The International Energy Agency has recommended coordinated government stockpiles across 11 high-risk minerals, estimating the cost at under $900 million a year. Genuinely cheap insurance against a supply shock. The IEA estimates could threaten $6.5 trillion in downstream economic activity if China fully enforced its controls. Government funding for the broader diversification effort did surge to roughly $65 billion in 2025, a real number rather than a token gesture. Footnote 11. But stockpiling buys time against a shock. It does not build a substitute source, and a stockpile drawn down during a genuine multi-year standoff simply becomes a countdown clock instead of a supply chain. Recycle. Global rare earth recycling rates currently sit under 1%, a strikingly low figure compared to metals like aluminum or steel, where recycling is a mature, high-volume industry. The technology to recover rare earths from old magnets and electronics exists in pilot form, and interest is growing in Europe, North America, and Japan. The infrastructure to run it at any meaningful scale does not yet exist anywhere, and building it faces the same separation chemistry and permitting obstacles Section 1 already described for mining raw ore in the first place. Every other locked room this show has opened has been about an actor protecting turf, a mutual hostage dynamic, a founding bargain, a relocated regulatory perimeter, or a demographic assumption quietly failing. This one is a different shape entirely and worth naming honestly rather than forcing it into a prior mold. It's not that the door is locked. It's that there's only one working locksmith left in the entire world, because every other locksmith's shop went out of business decades ago, and nobody else has finished training a replacement yet. Every door has a locked room behind it, but this one isn't hiding an incumbent, a hostage, a bargain, or a relocated risk. It's a locksmith monopoly, the one shop that stayed open while every competitor's storefront went dark, now the only one that can cut a working key for any door anywhere no matter where the original lock was made. Read this episode's timeline the way Episode 7 read the Strait of Hormuz Yuan tolls. Not as an isolated news story, but as visible evidence of choke point infrastructure that was already built, waiting for a moment that would make it newsworthy. The difference is the choke point itself. Hormuz is a shipping lane. This is a refining monopoly built over 30 years while the rest of the world wasn't paying attention to metallurgy. The November 2025 suspension is worth reading the same way this show reads G7 communiques, as performance sitting on top of a different underlying reality. The headline de-escalation covered the broad, extraterritorial October 2025 measures, the ones that would have been genuinely disruptive to enforce globally. It left the April 2025 heavy rare earth licensing regime, the one that actually touches magnet production, completely untouched. That's not an oversight. Keeping the lever that controls dysprosium and terbium operational, while conceding the lever that was hardest to enforce anyway, is a negotiating position dressed as a goodwill gesture. May 2020 SIXS asymmetric summit readouts, an American fact sheet naming specific elements, a Chinese statement naming none of them, are the same performance repeating itself a second time, not a new development. There's a broader pattern worth naming here that this show has tracked since Episode 4. Institutional and diplomatic language performs coordination and resolution, while the underlying leverage, capital flows there, licensing regimes here, tells the more honest story. What makes the rare earth case distinct from currency reserves or treasury holdings is how slow the leverage is to build and how slow it therefore is to erode. A country can shift bond purchases in a quarter. Nobody builds a rare earth separation facility, certifies its output for aerospace or defense use, and scales it to relevance in less than the better part of a decade. Everything this episode has built, the mining versus refining distinction, the 2010 precedent and its honest ambiguity, the dated 2023 to 2025 escalation ladder, and the locksmith monopoly shape of the problem, is the machine the next episode needs already running. A semiconductor export control is a policy choice one government makes about products it manufactures. A rare earth licensing regime is a policy choice one government makes about a chemical process almost nobody else on Earth has bothered to rebuild. Understanding which kind of leverage is more durable, and which side of the chip fight is actually negotiating from strength, requires knowing this machine exists first. None of this means the West loses the chip fight before it starts. It means the chip fight is being fought by one side with a genuine decades-deep structural advantage sitting one layer beneath the fight everyone's actually watching. And that advantage didn't require a single new law, a single new subsidy, or a single new idea. It just required everyone else to stop paying attention to refining chemistry for 30 years while one country didn't. Next time, what happens when the country on the other side of that advantage decides to point its own export controls at the thing sitting on top of it?